Well, if we look at this data here, and this is a fairly recent paper published in 2021, and they write this. At the elite or professional level, peak training volume can exceed 30 hours per week in weight-supported endurance sports, such as swimming, cycling, triathlon, and rowing, resulting in substantial exercise energy expenditures. Okay, so they're using a lot of energy because they're training excessively hard. That's not unusual. Furthermore, performance constraints of many sports also favour an ideal power or force to weight ratio. So things like in judo, for example, boxing, for example, incentivizing body mass composition manipulation via adjustments of energy intake. So in those athletes, we've got high energy expenditure, but also they are probably reducing the amount of calories coming in terms of energy to make the weight, to cut for the weight. The prolonged combination of these pursuits creates a perfect storm of potentially adverse outcomes of training overload. So this is adding an extra mix, and we've got our immunological responses. It's all going to connect in a moment. We've suggested that there are physiological responses. We've suggested there are immunological responses, and now we're suggesting that there may be a part to play here in terms of the relationship between energy expenditure and energy intake. Well, let's kind of look at this in a bit more detail. So here we've got our timeline here, and what you can see, this is kind of an acute training response. So in the acute training response, not surprisingly, the acute response is, well, performance, it's not an optimal performance, but performance may improve. But if we start to functionally overreach, let's say we're going to take the athlete on a warm weather training camp. If we allow the athlete to go on that training camp and we monitor performance over time and we allow them to have optimal recovery, performance should increase. That's what one would expect. But at the same time, this is one of the things we started to understand is that, particularly when they're doing acute training, we have to understand that there's generally kind of a good balance between energy intake and energy expenditure. Now, in this example, we're going to keep energy intake constant. But what we start to understand is as we start to go from kind of normal acute training, we start to go into kind of maybe the functional overreaching, our classic training camp scenario. What we start to get, we're training harder. So the energy expenditure increases. Because the energy expenditure increases, overall energy availability starts to decrease. You've got less energy. If you think about the Costill data that we showed right at the beginning of this lesson, where he took the athletes and doubled the training volume overnight, what he was really evidencing was significant decrements in muscle glycogen. So there's less energy available. And what they start to show is, not surprisingly, body mass starts to decrease. And as we move from functional overreaching to non-functional, this scenario starts to become magnified. And then what they've tied this to is what is called the red zone, and the red S symptoms. And it's relative energy deficit. So the relative energy deficit really is this balance between energy expenditure and energy availability. And so what we start to see is this zone gets bigger. And as this zone gets bigger, not surprisingly, performance starts to decrease. And we start to lose body mass. And we start to become more susceptible to illness and infection because fatigue is getting bigger, but we're not allowing for adequate recovery to compensate for that fatigue. So you suddenly get this multifaceted mechanism that is driving this underperformance-based response.